We want to look at classwork 3, and this classwork are so good for everyone that want to take his or her career on solar installation. Now, some people, when a client meets them, they don't know the first step that they needed to take. Number one is that you need to calculate the total load of that house, or you ask the client to tell you the total load that he needed to power the inverter with. That is what you are going to use. Now, this particular class work solve that area for every potential solar installers. Now, question number 1 on this classwork 3. Design a solar system needed to power the total load of a 3 kVA to enable it to run for 10 hours per day. Sometimes a client will meet you and he say, the total load I have in my house is 4 kVA or 4,000 kilowatts or 2,000 kilowatts or 1,000 kilowatts or 500 watts, as the case may be, or 5,000 kilowatts. In my factory, I have 10,000 kilowatts. Now, what is the total load? I mean, the size of the inverter that I needed. Give me the estimate. But from today, watch this video to the end. You will know how to approach it. And that is why we are looking at this important topic. Design a solar system needed to power the total load of a 3 kilowatts to enable it to run for 10 hours per day. A. What is the capacity of the solar battery you need in this system? B. How many solar panels do you need for this system if you are to use 625 watts solar panel? C. Draw the block diagram of the circuit. D. What is the total output current if you are using a 48 volts hybrid inverter? So now, we want to approach it with a simple method so that you know how to calculate your load. Serial number. We want to tabulate our system. Number 1 is ceiling fan. Number 2, electric bulb. Number 1 was if you add it together, let's add it together, have 3000 as a total. And this is how to tabulate and get the right thing. So this is how you can tabulate your readings of the items, the number of the items, so that you can get the exact and accurate design of your solar system. Now, we're supposed to put power factor into consideration, but that will be the next class that will put the power factor into consideration. So I want to clean this particular place now to enable me to do the calculation that we needed. So this is how we calculate. So at this time, you can use 2 ACs with the 2 freezers on this particular system. 2 ACs, 2 freezers, then other few lighting points, even with your laptop, to run for 10 hours. So we are looking at the total given load is what? 3000. Now the running hour per day is 10 hours. How do you calculate the battery capacity? The battery capacity is the total load times the running hours per day. That is going to be your battery capacity. Battery capacity, that is A. Is equals to total load times running hours per day. Total load times running hours per day. Now remember that our total load is equal to what? Total load is what? 3000. 3000 watts times 10 hours it will run is equals to 30,000 watts, which is equals to what? Watts hour, because this is hour, so which is equals to 30 kilowatts hour. This is your battery capacity. This is your battery capacity. Note, this is your total energy consumption per day with the 3000 watts load. Considering the region we are in, we are close to the line of equator. Now, because we are close to the line of equator, as we want to move on to calculate the numbers of the panel. Now, B, the number of solar panels needed. The number of solar panels needed in this system. Now, considering the region we are, We are close to the line of equator. Therefore, our output sun hour, our peak sun hour, are considered to be what? 5 hours to 5.5 hours per day. And if we are having 5 hours per day, then the total solar panel wattage needed is equal to what? Your total energy consumption per day divided by the peak sun hour. You divide it by the peak sun hour. That is to say that your total energy consumption per day, and remember that is the value of your battery capacity. Therefore, is what? Is equal to what? Battery capacity divided by peak sun hour. Is equal to 30,000. All over what? 5. Give you 6,000 watts. So your total number of solar panels needed for this system is 6,000 watts. Now, in this 6,000 watts, we want to look at how many pieces of 625 watts that you needed. If you are using 460, how many pieces do you need in it? So since we are using, in this calculation, we are using 625 watts of the solar panel, the total number of solar panel needed is this 6,000. Divided by 625 watts as an individual solar panel. So the solar panel, number of solar panel is equal to what? 6,000 divided by 625, which is equal to what? 9.6. Under standard temperature condition, we need, when you approximate this 6, we need approximately 10 pieces of solar panels. Under standard temperature condition, we need 10 pieces of 625 watts solar panel for this installation. But here, we are almost half of the irradiant. That is where the irradiant is put into consideration. Putting the irradiant into consideration is very, very important, because sometimes what you have from the manufacturer is not what you have outside when you come to the atmospheric irradiant. So, because of that, our irradiant is almost 0.5, and as such, we multiply this total panel, which is 10, by what? 2, to give us 20 pieces. So this 10 pieces now times 2 will give you 20 pieces of solar panels. For this installation. Question number B, the number of solar panels we needed. Because of the irradiance of this environment, your own may be different. You can get the equipment to test the irradiance around yourself so that you know if it's to multiply it by 2, or you can now use exactly what you design that comes out for you. Class work 3, question C, the block diagram of this system. Question C, draw the block diagram of the circuit. Now the block diagram, if you are using a parallels, it's a different case. Parallels inverter is a different case. But if you are not using a parallels inverter, non-parallels inverter, then we can look at it in this way. The block diagram of how you can connect it. This is solar panels now. Now, if you are using a parallel, non-parallels, we now can connect it. Now, as we look at this block diagram on the board, we don't just conclude, because the panel has its own parameters at the back. For the maximum power of this 625 watts panel is 625 watts. The open circuit voltage is 49 to 56. We are looking at the short circuit current is approximately 13.8 to 16. the voltage at maximum power, the voltage at maximum power is 40 to 47. Now the current at maximum power, voltage at maximum power is what we put into consideration. Current at maximum power is what we put into consideration. And current at maximum power is 13 to 15. So we want to look at it 15.2. So since these panels are run in series, remember that the current, the voltage that we are using now is what? 40. We take 40 as individual voltage. 40 volts. Now the current, individual voltage is 40. That's the maximum current, maximum current. That is current at maximum power and voltage at maximum power. So current at maximum power, we are using what? 16. While voltage at maximum power, we are using what? 40. Now, if we are using individual panel voltage, that's voltage at maximum power, give you 40. Now, current at maximum power, current at maximum power is equal to what? 16 approximately. So now we want to know how many volts will come here and how many amps that is expected to be here with this configuration. Now with this configuration, you see that you add it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This 10 now, we have 400 volts. Because when you connected in parallel, the voltage remains the same. Therefore, this one also gives us 400 volts. And 400 volts connected to 400 volts in parallel remain 400 volts. Now, the individual current at this time is what? 16. Now, when you are connecting in series, the current remains the same. And that is why the current at the output of this gives you 16 amps. The current at the output of this gives you 16 amps. So when you connect the 16 amps in parallel with the 16 amps, the currents add up, sum up. That is to say that the current now, the output current is equal to what? 16 plus 16 equals to what? 32 amps. The output current is equal to what? 32 amps. Since the series connection, voltage is adding while current remains the same. And in parallel connections, voltage is adding, voltage remains the same while current increases.